scientist is studying the number of bees and the number of wasps on an island. The number of bees measured in thousands, NB, is modelled by the equation NB is equal to 45 plus 220 e to the 0.05t, where t is the number of years from the start of the study. According to the model, find the number of bees at the start of the study. Well, that's going to be when t is equal to 0. So NB would be equal to 45 plus 220 because e to the 0 is just 1. So that's 265. And remember, it's in thousands, so it will be 265,000. Part B. Show that exactly 10 years after the start of the study, the number of bees was increasing at a rate of approximately 18,000 per year. So now we're going to need to differentiate. dNB dt. Well, the 45 is going to disappear. So it's going to be, remember to use the chain rule here, e to the 0.05t. When we differentiate it, we'll get 0.05 times e to the 0.05t. So we're going to have 220 times 0.05 e to the 0.05t. So we just need to do that 220 and times that by 0.05. And that is going to give us 11. So it's going to be 11 e to the 0.05t. So we want t equals 10. So we're going to have 11 e to the 0.05 times 10. And we want to calculate that. So we're going to have 11 times e, which is just there on my calculator, to the 0.05 times 10. That's 18.136, which is approximately 18,000 per year. The number of wasps measured in thousands, NW, is modelled by the equation NW is 10 plus 800 e to the negative 0.05t, where t is the number of years from the start of the study. When t equals big T, according to the models, there are an equal number of bees and wasps. We want to find the value correct to 2 decimal places. We should start by putting the two right-hand sides equal to each other. So 45 plus 220 e to the 0.05t will be equal to 10 plus 800 e to the negative 0.05t. For 4 marks, we can't just use a solver to do this. We're going to have to actually do some working. So subtract 10 from each side, and then that will be 35 plus 220 e to the 0.05t is equal to 800 e to the negative 0.05t. And let's bring everything over to the one side. I'm going to write it as 220 e to the 0.05t plus 35, take away 800 e to the negative 0.05t, and that will be then equal to 0. If we now multiply everything by e to the 0.05t, for the first term we would add the indices, and that will give us 220 e to the 0.1t. Then we'll have 35 e to the 0.05t. And with the last term, when we add the indices, we'll end up with e to the 0. So that one's just take away 800. Now, all of the coefficients divide by 5. The middle one is going to be 7 So what about 800 divided by 5? That's 160. And 220 divided by 5 is 44. And then we can let y be equal to e to the 0.05t. This one will then be y squared. So we have 44y squared plus 7y take away 160 is equal to 0. Now, let's use the quadratic formula in this. So y is going to be -7 plus or minus the square root of 7 squared, which is 49. Take away 4 times 44 times -160, all divided by 2 times 44. Now, clearly, one of the answers is going to be positive and the other negative. We're only interested in positive here because time started at 0. So let's see what y is equal to. So let's work out what's under the square root there. We've got 49 and it'll end up being plus 4 times 44 times 160, which is 28209. Let's just check that number. That was 28209 all over 88. So we can calculate the value of y, and it will be -7 plus the square root of 28209. And we just need to divide that by 88, which is 1.829. Now remember that the y was e to the 0.05t. And that means 0.05t will be the log of 1.829. And then finally, t will be the log of 1.829 divided by 0.05. It was 12.08 years.